And this is a very good evening to all the chief patron, the academicians present, the research scholars, and the fellow participants. So, as an outcome of my research program, I would be presenting on the land use dependent variability in soil organic carbon pools across the urban green spaces of Dehradun, which is the capital of the Uttarakhand state in India. Okay, so the background is that the urban soils are very important reservoirs of carbon, and the soil organic carbon varies with land use. And the baseline data for Himalayan cities are limited, and this study provides the first ever soil organic carbon assessment for the city of Dehradun. So as we all know, that soil is the largest terrestrial carbon resource and plays a very vital role in climate change mitigation, soil fertility, and ecosystem functioning. Now, urban green spaces, for the purposes of my study, I have been designated into these categories: the forests, the parks, the institutional campuses, the roadside plantations, and the railway corridors. And all of these are acting as important soil organic carbon sinks. So the objectives of this study was to estimate the soil organic carbon pool across the 5 major urban land use categories in Dehradun: the forest, the institutes, parks and gardens, roads, and rails, to evaluate the spatial variability of the soil organic carbon pool, both within and between land use groups, and to determine the primary soil physical and chemical drivers of SOC pool fluctuation, and to offer evidence-based suggestions for soil organic carbon-based urban green space management. Dehradun is the capital of Uttarakhand and is one of the fastest growing cities in the Indian Himalayan region. It is located in the Doon Valley in the foothills of the Shivalik range, and the city represents a unique Himalayan urban ecosystem. Despite its relatively small geographical area, Dehradun comprises of diverse urban land use categories, which include the forests, institutes, parks and gardens, roads, and railways. So this is the result of the study. So we can see the mean soil organic carbon pool in the forest was around 59.89 tons per hectare. In the institute, the mean was 25.79 tons per hectare. In the parks and gardens category, which recorded the maximum SOC content of 82.67 tons per hectare, the road recorded the least SOC content of 14.65 and rail of 26.05. Now within the forest, also there was a large intervariability in the strata, wherein we had carbon levels, SOC carbon levels as low as 5.32 and maximum as high as 95.34. And similarly for the institute also, we could see a lot of variation from 6.63 to 87.89. However, parks and gardens was very consistent, ranging from 71.72 to 82.67. In the rails, which recorded the least SOC content, also the variation was not much, between 13.18 to 14.65. And in the road strata also, it varied from 22.35 to 26.05 tons per hectare. And this also, you can see the coefficient of variation. And this is the sample distribution by land use category, because forest was the largest strata. So this was area proportioned sampling. So we had maximum of our sample plots in the forest strata, followed by the institute strata, followed by the roads, then the parks and gardens, and then the rail strata. So as I already discussed, there are a total of 135 soil samples were analyzed across 34 urban green space sites, and the SOC pool ranged from 5.32 to 95.34 tons carbon per hectare, with an overall mean of 48.55, and the SOC storage differed markedly in the different land use categories. The parks and gardens recorded the highest SOC mean of 82.67 tons of carbon per hectare, followed by the forest strata, which recorded around 59.89 tons carbon per hectare. The rail strata recorded 14.65 tons carbon per hectare and was the lowest amongst all the stratas, while the institution category recorded 25.79 tons carbon per hectare, and the roads recorded 26.05 tons carbon per hectare. The institutional sites showed the highest variability. The CV was 79.64%, whereas the parks and gardens showed the most consistent SOC storage, and the CV was just 9.29%. We can say this land use was significantly influenced the SOC pool. The Krush-Wallace test was also used, and we found that the forest contained the highest individual SOC values. And while the parks and gardens had 100% samples in the high SOC category. Now we have categorized into, if it is less than 40, then it is low. If between 40 and 65, it was in the medium, and more than 65 in the high category. So the road and rail were classified in the low SOC, indicating a depleted soil carbon. And the SOC concentration was the strongest predictor of the SOC pool, with the Spearman's coefficient of 0.952 and a rho of 0.001, while the bulk density and the coarse fragments showed no significant overall relationship. Overall, the vegetation-rich land use stored substantially greater soil organic carbon than disturbed urban land uses, highlighting the importance of urban green spaces for carbon sequestration. So the urban land use significantly influenced the soil organic carbon pools, with nearly six-fold variation among the land use categories. As I've already discussed, that parks and gardens exhibited the highest SOC storage of 82.67 due to continuous vegetation cover, litter accumulation, and minimal soil disturbance. Overall, we can say that the urban forests act as major carbon reservoirs, whereas the institution, roadside, and railway soils showed lower SOC pools because the vegetation loss, soil compaction, construction activities, and reduced organic matter inputs. The SOC concentration was the strongest predictor of SOC pool variability, whereas the bulk density and coarse fragments had limited influence. Compared with other Indian metropolitan cities, Dehradun exhibited relatively high SOC storage, highlighting the ecological importance of Himalayan urban green spaces. So this study provides the first comprehensive assessment of SOC pools across the major land use categories in Dehradun, Uttarakhand. A significant SOC hierarchy was observed: parks and gardens, followed by forests, followed by rails, followed by institute, followed by road, followed by institute, followed by rail. And parks and gardens functioned as the most effective urban carbon sink, while road and rail corridors represented the most carbon depleted environments. Conservation of urban forests and parks, increasing tree cover in institutional campuses, and restoring roadside and railway vegetation can substantially improve urban carbon sequestration. The generated data sets provide a baseline for regional carbon accounting, sustainable urban planning, and climate change mitigation in Himalayan cities. Thank you. That's all from my side.
Yeah, thank you so much, ma'am, for the nice topic, ma'am. You're from the this one forestry background,
Right.
and yes, ma'am, you can close the slides, ma'am, so that we can have one good discussion from your presentation. And it was a very nice presentation, ma'am, you have given, and from the Uttarakhand, and we know that it is highly greenery. So it was coming in my mind one question, ma'am, that how can drone technology, ma'am, have you done any concept of the study, ma'am, about the GIS AI-based concept drone technology to improve the forestry in Uttarakhand, ma'am?
Ma'am, this is not part of my study, but
Yeah.
yes, drones have been used in many of the state forest departments for using seeding, for dropping seed balls. So seed balls is one of the methods of afforestation of barren areas, because seed balls, when mixed with organic carbon and soil, the seed stays intact. And whenever it is dropped onto harsher climates, it gives a better opportunity for the seed to grow. So drones have been used extensively in many states for dropping seed balls. But yes, for parts of my study, no. This is all field-based exercises which I have done. Quadrant-based studies only I have done.
Yeah. Yeah, but very nice topic, man. I think this can contribute to the rural livelihood in the Uttarakhand, right? Okay.
Yeah.
So here I would like to go for a good discussion with our Honorable Director, sir.
Thank you for unmuting me. I congratulate Richa Mishra Madam for a very excellent and very unique and it is